All right, so in lesson 9-7.1, we're going to be starting to talk about systems of equations. So we've talked about in the past before that if you have an equation with one variable, there is one solution. But we've also talked about if you have an equation with two variables, like a function, you have a y and an x somewhere in there, like y equals 3x plus 2. You have an infinite number of solutions when you have two variables. Okay, however, if we have two equations with two variables and they're the same variables, we can actually find the solution for those two equations because think about an equation, y equals mx plus b. What you're going to get is you're going to get two equations or two lines. Let's go with the whole coordinate grid. Okay, let's say I have one line that looks like this, and then I have another line that looks like this. Well, where is the solution to those two equations? Right there. Okay, so yes, there are an infinite number of solutions. It's all the points on the line. But where do the two lines meet? That's the solution for what we call systems of equations. So today we're going to solve systems of equations by graphing. You think about, how we learned how to find the slope of a line. We did that by graphing first, and then we introduced a more mathematical way of doing it using the points, and we used an equation y2 minus y1 over x2 minus x1. Well, there are more mathematical ways of solving systems of equations, but the first way today that we're going to talk about is solving by graphing. So we're going to have some graphing involved in today's lesson. Systems of equations is two or more equations that have the same variables. Okay, the solution means values for variables that make an equation true. In this case, it's where the lines intersect on a graph. Okay, so for this slide here, okay, here's our traditional intersecting lines, the number of solutions. We have one solution because we have two lines, they meet right here at that point. That's our one solution. So what's the description? It's the point of intersection. All right, now what do we have here? It looks like we have two parallel lines. It doesn't look like they're ever going to cross. They're always going to stay. They're always going to stay the same distance apart. So we're actually going to have zero solutions when we see parallel lines. So parallel lines offer us zero solutions. So we can write parallel lines here for the description, and we have zero solutions for that. Now, how many lines do you see in this graph? You may see one, but I actually see two. Think about how I could see two lines. Since there are two lines there, the number of solutions are actually infinite. And we can use that symbol with a sideways 8. That's the infinite symbol. And the reason why I have two lines is because both lines are right on top of each other. They are the same line. They have the same equations, like y equals negative, 2x minus 1. And then the other equation is y equals 2x minus 1. They both are the same line. So we can, the description there, we can say same line. They share a line. So we could say share. So therefore, they have an infinite number of solutions. Okay? So now think back to what we learned in chapter 9, part 2. What did we learn about parallel lines? Okay, we learned that their slopes are equal. So that's going to help us for today. So let's get into the lesson a little bit more here. Look at our first example. It says solve the systems y equals negative 2x minus 3 and y equals 2x plus 5 by graphing. Okay, just by looking at these two equations, I can't tell you where they're going to meet. However, I can graph them and find where they cross, where they intersect. So they are in slope-intercept form, so the y-intercept here is at negative 3, so I can start with that point. Okay, and then my slope is negative 2, so that means I'm going to go down to right 1. I can also go up to left 1, up to left 1, up to left 1, okay? You might be wondering, how many points do I need to make? Well, you just need to make as many as you need. At some point, these two lines are going to cross. So let's get the other line going. I'll change colors here so it's a little bit easier to see. So 2x plus 5. So 5 is the intercept, and 2x is the slope. So I'm going to go down to left 1, because this would be a positive 2. So it's like up to right 2, or right 1, excuse me. I'm going to go down to left one. Ooh, look at that. I just crossed over the same point. So that's my intersection right there. So now what I need to do is just draw in my line. Okay, and then I'm going to switch back to my other color. I'm going to draw in my other line. Okay, it is important to have these lines in there, even though we know what our solution is now. And this point right here is our solution. So the solution is -2, 1. That's my coordinate. Okay, now what I need to do is, since my answer, what I think the answer is -2, 1, I can go to the next page here, and what I need to do is I need to plug it in. So I'm going to plug -2 in here. I should get 1 out. And then I can plug -2 in here, and I should get 1 out. Okay, so -2 times -2 is +4, and 4 minus 3 is 1. So it worked. 2 times -2 is -4. -4 plus 5 is +1. So that one worked as well. So that's where we can find the solution of 2 equations. All right, so if I'm given 2 equations. Now, why do these things actually cross? Well, because we'll kind of get into a little bit later, is my slopes are different. We know that if the slopes are the same, I'm going to have parallel lines, which, remember, parallel lines, we don't have any solutions. So if I have different slopes, I will have exactly one solution. And then if it's the same line, obviously the slope would be the same, and the y-intercept should be the same as well. So it's the same exact equation. All right, let's go ahead and keep going here. Okay, solve the system's equation. Again, they are in slope-intercept form, so they are ready to graph. So here's my -1, and then my slope is 1. So I'm just going to go 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, again, I don't know how far to go. You just need to go as far as you need to go. All right, so let's switch colors. We're going to go with -2, and I'm going to go up 2 over 1. Okay, so there, I already know where they cross. I can draw that line in, and my point of intersection is right here. All right, so my solution is 1, 0. That's where the 2 lines meet. That's where they cross, okay? All right, so now I look at this one right when I start, and they are not in slope-intercept form. So what I need to do is add 2x to both sides. Okay, when I draw my line, I'm going to get y equals 2x minus 1. And then over here, I have y equals 2x. Well, right away, what I notice is that the slope is 2, and this slope is 2. And what I remember from Chapter 9, Part 2, is that if you have the same slope, they are parallel lines. So let's go ahead and graph that. We have -1, and then we go up 2 over 1, up 2 over 1. Okay, I can go ahead and graph it. And then we have y equals 2x. So y equals 2x. What is b? Remember, y equals 2x plus 0. It goes through the origin. So we're here, and I go up 2 over 1, up 2 over 1. Again, I can graph that. They're going to be really close together, but they're never going to touch. They are parallel lines. So what is the solution? We would have no solution, and it would be good for you to write parallel lines. Okay, now, sometimes you might ask, well, if I notice that, do I actually have to graph it? Well, here's the deal, okay? The graph is you showing your work. So if you don't want to graph it, then over here, you're going to have to give me a nice explanation, like a couple sentences. You would have to tell me there is no solution because these lines are parallel. And I know that they are parallel because both lines have the same slope, but they have different y-intercepts. Because if they had the same y-intercepts, then they'd be the same exact line, which then there wouldn't be no solution. It'd be infinite solutions. So again, you have to give me an explanation if you're not going to graph it. I'm okay with you not graphing it as long as you give me an explanation. All right, so let's look at the next one. These are both in slope-intercept form. Again, right away you'll notice that I have a -3 slope and a -3 slope. My y-intercepts are different, so let's go ahead and graph that. Let's go -2, and my slope is -3, so I'm going to go 1, 2, 3, and over 1, and I'll go up 1, 2, 3, and over 1. Okay, I'm going to go ahead and graph that line. Okay, and then over here I have -3x plus 4, so I'll change colors here. Here's my plus 4. I will go down 1, 2, 3, and over 1. All right, I'll go ahead and graph that just with 2 points. Now you can see these are both parallel lines. They're never going to touch, so therefore we have no solution, and they are parallel lines. Again, if you don't graph it, that's fine. I'm fine with you not graphing it. However, you have to tell me more than this. You have to tell me no solution because they're parallel lines. And I know that they are parallel lines because the slopes are the same and the y-intercepts are different. So you have to really explain that to me if you're not going to graph it. Okay, let's check out these two. Y equals 3x minus 2, and this one is not in slope-intercept form. So let's add 2x to both sides. And I'll draw my line. So we have y equals, okay, x plus 2x is going to be 3x minus 2. All right, so if I look here, it's y equals 3x minus 2 and y equals 3x minus 2. Well, that looks familiar. Okay, so what I have here are infinite solutions. Same line. Okay, so my handwriting there is a little poor on the smartboard like this. So let's go ahead and graph it. We have -2, and we're going to go up 1, 2, 3 over 1. You only really need to graph one line because they are the same. And that's it. Okay, now again, if you don't want to graph it at all, you need to do some more explaining. You could say that it's infinite solutions because I see that both equations have a slope of 3, and both have a y-intercept of -2. Therefore, they are the same exact line. Okay, again, you need to explain to me what's going on, and then I'd be fine with you not graphing. So again, here, we need to get this one in slope-intercept form, so we got to subtract 2 on both sides. Draw my line. I'm going to get y is equal to 2x minus 5. Okay, and then I look at this one, it's y equals 2x minus 5. So again, infinite solutions, same line. Now this is all I'm writing because I'm going to graph it. Okay, so if you want to graph it, that would be all you have to write. So I go -2, I go up 2 over 1. There's my graph, or there's my points, and there's my line, and I'm done. So I don't have to write anymore if I'm going to graph it. Okay. Now if you don't want to graph it, that's fine, but you have to say there are infinite solutions because these lines are the same. I know that they're the same because the slope is 2 for both of them, and the y-intercept is -5 for both of them. So therefore, they are the same exact line. So again, I don't mind if you don't want to graph it for both no solution and infinite solution, because you can recognize right away that, hey, it's the same slope and they're different intercepts, or hey, it's the same slope and they're the same intercepts. I get it. You can see the difference. But the ones that are different slopes, they will always have a solution. So like this one, we had the slope was 1 and the slope is 2. Okay, these are different. So you have to graph them, and you have to find the one solution right there. Okay, so that's our last example for today. Good luck with that.